Welcome back to the workshop. This is going to be session number 7, specifically on the programmable safety relay 440C-CR30-22BBB. We've covered a lot of technical details and some that include some details you didn't really want to know, some of you. My philosophy when I do these videos, since I'm doing them free, not all of them end up being free, but primarily when I do them, they're free for some period of time. I don't worry about the folks that already know a lot. My concern is for the people that are struggling to figure out how to use these things, how to program these things. That's PLCs, PACs, HMIs, VFDs, whatever it is. So my approach is to go slow and cover a lot of details, and then once in a while throw some stuff to the bit heads, the space cadets. And so in this session, though, we're doing circuits. So we may discuss technical things, but at this point, we're going through and doing circuits one at a time. And the last session, we started with an almost unusable circuit, but we wanted to demonstrate the relationship between a 2-channel EStop push button and the CR30. And then we added to it, to two of the multi-purpose outputs, we connected up two safety relays. We call them safety relays. They're force-guided contacts, which means all the contacts change state or they don't. So with non-force guided, you could have contacts that are welded shut, welded closed, and when you do de-energize the coil, some of them open, some of them don't. Those aren't force guided. If they were force guided, all of them would remain closed. So let's jump in and do this next circuit. This was the last circuit that we covered in session 6. And to reiterate how simple it is, now we did end up adding to terminals 18 and 19. Those are two of the output. They're not special purpose. Special purpose or dual purpose, multi-purpose are 12 through 17. 18, 19, 20, and 21 are pretty much straight up DC outputs. We added two relay coils, one to 18, one to 19, so we had something to turn on and off. This was the basic safety circuit that we did. Now we're going to let this evolve a little bit, and we're going to remove the power from the EStop channels 1 and 2 from 24 volts DC, and instead we're going to get our source from terminals 12 and 13, which 12 and 13 are two of the 6 multi-purpose outputs, 12 through 17. So we're going to take 12 and 13, and we're going to use that to encode the power going to those contacts. With the old circuit going straight to 24 volts DC, you could jumper out either one of those or both of those contacts. Now, you'd have to be clever about how you did it, but you could do it. You could take and put a jumper from 24 volts DC to inputs 0 and 1. So if we jumpered across there, in other words, somebody in the field, maintenance person, operator, somebody, engineer, anybody, could jumper across those, and then when they hit the EStop, nothing's going to happen because 0 and 1 are still getting 24 volts DC. But with this circuit, we now have taken the source for channel 1 and channel 2 into the CR30, and we're going to produce something on terminals 12 and 13 that's, for all practical purposes, impossible to fake from the outside. Another thing I wanted to mention before we went too much further, and that is the circuit operators push, pull, maintain. This is the kind of EStop button that we're using, push, pull, maintain, meaning, well, actually ours is a twist. This one, if you hit the EStop, it stays in. Now remember that with the configuration, the program that we're using right now so far, is when you pull out the EStop, that resets it. If this were not maintained, then you push it in and it powers off the safety outputs, but when you release it, it pops back out and it's reset. That would hardly stop the machine in an emergency. This is push, pull, maintain. So you hit it, it's latched in the depressed position. Now this is push, twist, maintain. This is actually what we're using. I have a real El Cheapo. I would not recommend it for the real world, but it's good enough for training. And you push it, it opens the contacts, and it stays depressed. Then you twist it to release it, which is more deterministic than just pulling out on the first one we showed there on the left. This one, you actually have to twist it, a little bit more deterministic method of resetting it. And then, of course, push, release, momentary. This would not work with the configuration that we currently have and we went over in the last session, because if you pushed it, as long as it's depressed and you're holding it down, then the safety outputs are stopped. They're de-energized. But if you let go, it goes right back to powering those safety outputs. So let's go in and look at our new circuit. I'll back up here real quick. One more time. We removed the power side of those two contacts for that EStop. We removed it from 24 volts DC, and then we attached them, landed them on terminals 12 and 13, and we're going to do something inside of the CR30 to create something that you can't fake out. If we move those wires to 12 and 13 without reconfiguring our program with Connected Components Workbench, it would not avail us anything. So let's go play with that. I permanently moved these terminal blocks for power and for channel 1 and channel 2 from here over to here to make it easier to observe what was going on with the wiring. The other thing I'm going to do is disconnect the Ethernet cable temporarily so it's easy to see what's going on. Now remember, this is the circuit we've already covered. All I did was move the terminal blocks from here over to here. Now what we're going to do, instead of supplying channel 1 and channel 2 with 24 volts DC from our power supply, instead we're going to source 12 and 13 up here to channel 1 and channel 2. So I'm going to pause, move these two wires right here, yellow and purple, up to here, and then we'll resume. We just looked at the hardware, and we moved the source for channel 1 and channel 2. We moved it from 24 volts DC to terminals 12 and 13 down here. However, the controller doesn't know that. So let's go to Edit Logic, and I don't have my Ethernet plugged in. Which we would not have to do in order to reconfigure this, because we need to be offline to do it anyway. So we're still going to have immediate off. What we're going to do, though, is we're going to go over to our safety monitoring, SMF1, safety monitoring function 1, which is the EStop button. We still have two normally closed, but now we're going to enable pulse testing. And we have to use two sources. It doesn't give you a choice because you have two inputs. It's going to be looking for two unique sources. What that should tell you right off the bat is that when you configure it this way, what appears on terminal 12 is different from what's on terminal 13. That way you can't cross them, which means that the pulse testing is not going to be in phase, so they are not synchronized. But because the controller generates the test pulses, it knows what to see on inputs 0 and 1. We can leave the discrepancy time the way it is and the input filter. So that's really all that we've changed, is we've added or put back in. Remember, by default, when you picked the emergency stop safety monitoring function, it picked input 0 and 1 by default, and it picked test source A and B for pins 12 and 13 by default. And by default, it was pulse testing was two sources, and the inputs were two normally closed. Now, you could, if you use one normally closed, that would have to be a single wire. That would be a single channel. So that's all we had to change. Now let's save that. And I'm going to save it as, okay, we saved it as, and we changed the name slightly just so we can always go back if we need to. So we go back to Edit Logic. We did save it as Pulse 1. See up here in our title bar. Now we're going to download it. In order to download it, we have to go back to the GuardMaster page or tab. Go over here to Connect, and we need to connect to the device. And of course, there it is. We would expect nothing less. Then right away, it checks, and it says the projects don't match. And of course, we don't want to upload the one that's in there because that's the one that we just edited offline. So download current project. It says it's going to put it in the program mode. You can see right here it's no longer in the run mode. Successful. Do you want to go back online? Yes. So now we'll go back to Edit Logic, and now we have, it's green now. And if I were to look at the CR30, it's not faulted, but guess what? It's no longer verified. If you were looking at the CR30 right now, you would see that that run light is flashing. Now, I don't see anything immediately on the screen here to tell me that it's not verified, but the flashing LED is enough. So if we go back to the GuardMaster tab, and here's where we verify it. Click on Verify, answer all these questions in the affirmative. Remember, you're saying you did all this. Whether you did or didn't, that's on you. Generate, yes, and I just heard it click behind me. So now we'll go back to Edit Logic. Go to Edit Logic, and you see everything's green, so let's do an EStop, and you see that it stopped. So it turned off embedded outputs 18 and 19. This being all grayed out, everything's all grayed out. One thing that I don't like about this screen is that you can barely see these gray lines that go from dot to dot passing through. Now when they're green, they're somewhat visible, but when they're gray, they're even hard to see looking right at the screen. So keep in mind that you wouldn't have these pass-throughs unless there was a connection between there and there, there and there, there and there. So it is connected. Now it's reset. Remember, we're still in auto, okay? Right here, we're still in auto reset. That means when we pull out the EStop, and I tried to do it slow, and I was successful in doing it slow, and I got a channel fault and a discrepancy fault. Read channel fault. One channel went to the safe state and back to the active state while the other channel remained active, or one channel was in the safe state after a reset. A channel fault is not the same thing as a discrepancy fault. A discrepancy fault is that the contacts were inconsistent, meaning that they were different for and exceeded a certain length of time, which in this case is 50 milliseconds. A channel fault implies something completely different, but we're able to create that simply by how we pull the EStop back out. So let's reset it. I've depressed the EStop and then released it quickly. Let's go look at the hardware. Now you see I've made the changes. So I moved the two wires, both this yellow and purple were attached to 24 volts DC down here. I moved them up to outputs 12 and 13. But remember, I've not changed my program yet. When I disconnected them from 24, because I didn't do them simultaneously within 50 thousandths of a second, then I got a fault. So you can see up here that the fault light is on, and that's the reason it's on. I can't reset it though. The reason I can't reset it is because we have not configured 12 and 13 to supply test pulses to channel 1 and channel 2. So let's go do that. This is something that occurred when I was moving some wires around on the unit. I'm not sure what caused it, but I thought I'll just record clearing it and turn it into a learning experience. I was disconnected, and I know I disconnected the Ethernet while it was running, but that shouldn't make any difference. So I reconnected, and then this showed up, type 1 processor hardware fault. Host detected incorrect. Let me get that up there again. Safety firmware version. See fault view for further information. Okay, well, where's the fault view? You look all over, and that might be it right there. So we click on that. I see the recent faults. Communication error, and I don't know if these were all at this moment or some of them are old. But since this is fault index number 10, configuration fault, the application has been in run mode for 24 hours without a verification ID. Ah, excellent. So let's see if we can exonerate this situation. I am connected, but I can't verify. If I go to edit logic, everything looks good. So now I have to figure out some way to reset the fault. If I refresh the fault log, that's not going to do anything. I don't want to export it. I don't need to see it. I need to reset the fault. So I'm guessing I have to re-download. I'm going to go to edit logic. Everything looks good. Go back to the device tab. Go up here. Go offline. Download. Download failed. So let's download from here to see if we get anything different. I doubt we will. I believe we have to be online to download. Now, it doesn't mean that Rockwell can't change the software, so if you're offline and you select download, that it doesn't do both. But it's not doing both, so let's try connect to the device. So I got rid of this fault by cycling power. I did not find any information on the screen or in CCW to that end. I went to the manual and I could not find the information I needed, the user manual. And then I went online and did a search for CR30 type 1 fault, because the type 1 was the original one that we got. And then we ended up with a type 5. That one I understood more directly. It was a communication fault because I did unplug Ethernet. But I wanted to add this to the learning experience for anyone watching this video, that I was able to get rid of the fault by cycling power to the CR30. First thing to notice is that the run light is not blinking. I will turn off some of the illumination to exemplify that. So you see right here, the run light is solid, which means it's been verified. And there's really not much to demonstrate here. You can see that we're running 12 and 13. 12 is channel 1. 13 is channel 2. That's our pulse source. Comes into this block and then goes over into our 2 contacts and back out and over here to input 0 and 1. So if I depress that, you can see by looking here, remember yesterday I showed you, if you look right here and here, you can see those going on and off, see? We'll try doing it real slow to see if we can fault it. Yep, we did. Look over here, you got a fault. Okay, to reset the fault, we pull it back out. Now, in other cases, you might have to do a little bit more to reset it, but in this case, off, on. Well, actually, these right here show that they are on, now they're off. I don't think we can squeeze any more out of this application, and I do like the new position of these blocks here because it kind of keeps it out of the way. This cable's in the way of your view. I'm sorry about that. Nothing we can do about it. By the way, I do recognize that when you're listening to this video, that when I'm using this camera, you're only getting sound really primarily out of one channel, not stereo. And it may be because I don't have a microphone on this camera. Now, the camera has a built-in microphone, but it's not very effective. I've ordered a microphone that I can use to give us better sound. There we are. That's the end of this session, and we're going to continue on doing circuits. So if you're getting bored at this point, you might want to jump ahead to see if there's a part 8, part 9, part 10, and find something more interesting. But please keep in mind that it's not about us, okay? It's about the folks out there that are drifting around through the manuals trying to figure out how to get their safety application to work. This is a wonderful device. It's not perfect. CCW is not perfect, but with a little bit of help, we can get this done. Thank you for watching.